Hey folks, welcome to API Hacks Workshops. Today we have Jai with us. He is a software engineer at Carl Zeiss and has doing amazing work in the developer community and helping us to know about gRPC and why we are like gRPC over REST. So over to you, Jai. All the best for the session.
Yeah, thanks, Avir. Yeah.
Yeah.
Okay, yeah. Let me just share my screen. Great. Okay, so yeah, in this session, I'll be covering mostly about gRPC and I'll try to. gRPC is basically a system to create APIs or RPC APIs to be specific, but I'll try to compare them with REST because REST is something which most developers get to know whenever they first learn about creating APIs. So that's why I added the term REST because that will help you understand gRPC, compare gRPC and understand where it stands and what differences there are between gRPC and REST. Okay, so let's get started. Okay. So yeah, before starting, like modern software development is very much moving towards distributed. People are trying to break down their big monolithic servers and make it as much distributed as possible. And that is like there are a lot of and it's not just a hoax that everyone is doing this. There are definitely a lot of advantages. Like you can building software easier because now you can build each microservice in isolation. Scaling system easier because whichever service has more load, whichever microservice has more load, you can scale that microservice up, as well as management of code is easier, as well as developing and adding features into that microservice is easier. So yeah, modern software is moving towards distributed. That is a very well accepted and known fact. If you have been if you have been active in the community and the development ecosystem. Yeah, so that is taken. But let's talk about some examples. Okay, I hope every one of you know about this company, Spotify, right? It has around 2,500 services. So services, by services, I mean microservices. So there are 2,500 different services. They have around 1,000 developers, around 250 teams, and they work with Java, Python, and even I don't know what else. So there might be more things. And this is not the latest data by any means. This is I got this data from a talk by Mathis Gruther. I don't know how to pronounce his name. In from April 2019, I think. Yeah. So it's like 2 years old data. They might be having more at this time. So yeah, even a company like Spotify is moving towards microservices and distributed development, distributed applications. So okay, gRPC. Okay, before that, yeah. Uh, so Spotify has around 2,500 services, right? And these services are not in any ways uh, they are isolated, like they are running in different containers or environments, you can say, but they have to communicate with each other. And if I were to ask someone, how would you make them communicate with each other? The simplest solution would be to create API endpoints for each service, and then each service can use, like, suppose Spotify has different services. Let's name them. Okay, there's a player service which streams the song which you're listening. There's a recommendation service. There is a notification service. There is a what else? So yeah, like there are these three services. Suppose if the recommendation system creates a new recommendation playlist for you, then it needs to send in notification to you that hey, we have this new chill vibes playlist for you. So maybe try listening to this. So the recommendation system will like to talk to the API system. So they need to communicate with each other. So one simple solution is to create REST APIs. So the recommendation system can send the recommended playlist to the notification system. The notification system then can notify the user that hey, this is a cool new playlist we created for you, and blah 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 blah. That's one way to do this, and for that you'll need to create REST APIs. Okay, but REST APIs have their own pitfalls, and I'll try to go over them, and I'll try to explain why even Spotify uses gRPC for their own microservice communication and stuff like that. And before moving forward, gRPC at this current moment, at this current age of time, is mostly being used for communication between microservices or communication between two different services. So it's not very what is the term? It's not very. It doesn't support web very. It does support web, but it's not very. Can I say? It's very new. It's in very development phase. It's not production ready. Uh, the At least the web stuff, but the interprocess communication between microservices to microservices is very much production ready, and Spotify is using it. So yeah, it's really efficient and yeah. Okay. So gRPC and an alternate to internal APIs, alternate to internal REST APIs actually. So I'll talk about a bit on gRPC. gRPC is an open source project actually. So you can go ahead and go to gRPC's GitHub repository, check out its code base, and yeah, uh, and do all the open source stuff. Yeah, and gRPC in gRPC, the RPC stands for Remote Procedure Call, and it's a RPC system basically initially developed around 2015. It's not exactly developed; it was released in 2015, and it was an internal tool used by Google way before. But then in 2015, 2016, they decided to release it to public and made it open source. It's part of a cloud native computing foundation. So since and the importance of this is that uh, Spotify chose to use gRPC only because CNCF supports gRPC, not supports. gRPC is an incubation project under CNFC basically. So that's a stamp mark of saying that gRPC is here to stay, because Google is not very good, does not has a very good name in terms of supporting things. Google likes to kill its own projects very quickly without thinking twice. They probably do, but yeah, that can cause a backlash. But yeah, since it's supported by CNFC, uh, we can pretty much say that it is here to stay, and you can pretty much use this in your own company as well or in your own project. And yeah, it's basically the next version of Stubby. Stubby was the internal tool which Google used, and it turned out to be very efficient in Google's case, and hence they uh, chose to share this with the whole world and made it open source. And yeah, yeah, this is all cool. But then in gRPC, RPC, what does actually this remote procedure call uh, means? Okay, so let's talk about RPC first. So yeah, RPC stands for remote procedure call. Let's break this down. So procedure call. A procedure call is basically a function. You probably have written functions a lot. Yeah. So procedure call is basically another word for function, and remote is basically something which is in your local machine. So a remote procedure call is basically a function call which you're making, but it's not being executed in your remote machine. So it's kind of like an API, but in API you are hitting a like what you do is you call the API which is a URL. But in RPC, what RPC is a but in RPC, what we do is we call a function, and the function in calls we call a function which is on the remote machine, and this request goes to the remote machine. The function gets called, and the response gets back delivered to us. So it's basically an API, but instead of calling a URL, we're calling a function. And yeah, it's basically a principle. It's not a protocol or something. It's basically a principle of how we should call APIs or how API should be defined. REST says that APIs uh, in REST, you usually see APIs which are URLs, but in RPC, the things which we call are basically functions. and the internal sending the data and returning the data is handled internally by the RPC framework or whatever you're using. In this case, we'll be talking about gRPC. So yeah, and the last line says you can implement RPC using SOAP over HTTP, REST over JSON, and over a simple HTTP as well. So it's all up to you. RPC is basically a principle uh, telling you how things should look to the end user or the end developer. So the end developer should only see a function, and he should be able to call that function, and the function should be executed on some remote machine, and the execution result should be delivered back to the developer or whoever called the function. So that's just a principle. Okay, yeah. Yeah, so in basically simple terms, RPC is calling a function which is being executed on a remote machine. Okay, now here comes the difference between REST and RPC APIs. So RPC APIs, think about them in terms of verbs. So they are usually defined or written in terms of verbs. Okay, so in the example, in the below example, you can see there are two different endpoints I've written in RPC framework, and in RPC methodology, and in REST as well. So usually, if you have to get some data in REST, you should have an API called a slash data, whereas in RPC you should have a slash get all data. So the get all data is a verb which has the get as well as the data both. Whereas in REST, the get part is usually the headers, right? We have different API, get API, post API. So if we have to get and data, we'll do a get request on the data endpoint. If you have to post some data, we'll do the post request on the slash data in the REST framework. Whereas in RPC, we'll hit the direct endpoint, which is named as get all data or post data. So the names are usually like functions. Uh, the names are usually like verbs, which are also how functions are defined. So yeah, that's what RPC, and yeah, these are the same things. Actually, I don't think we should go over this. Okay, so yeah, let's start talking more about RPC in details. Like I'll try to. This might get boring, but yeah, I have some very nice demos up in almost at the end of the presentation. So yeah, just bear with me for 10 minutes more. So gRPC, basically what Google did was they took the old RPC design framework, design concept, and believe me, RPC existed in this developer ecosystem way before even REST came along. So RPC was even before REST came. RPC dates back to SOAP and all when XML was used. So gRPC, Google took the old RPC design system concept, and they took it and they tried to create a refresh system on that concept, and they called it a Stubby, which was their internal uh, tool. And after it was released to the public, it's now called gRPC. And yeah, basically the main concept is that it's interoperable, so you can use this with n number of languages, different languages and all. It's modern, it's efficient, and by efficient I mean I'll talk about how it is efficient more. So yeah, so these are the main key benefits. It's lightweight because it uses binary instead of JSON. So the data which goes between two different systems is in binary instead of JSON. So the parsing of JSON is something which gRPC calls don't have to do, because parsing of JSON will definitely take some CPU cycles. You can argue with me that it's just like this much CPU cycles. Nowadays CPUs are so efficient that it doesn't even matters. But when you talk about a company, Google, which created this system, they probably have like billions of requests each day, or maybe in each hour. So even 2, 3 milliseconds would be way too much for them. Way too much. If they could even cut down 2, 3 milliseconds of execution, they'll save so much time. So at that level, even just skipping the parsing of JSON saves time. So it's lightweight, it's high performing. So depending on the evaluation you do, gRPC is probably around 5 to 8 times faster than REST plus JSON, and this has a lot to do with how gRPC works internally. And I'll talk about that as well. How 5 to 8 times it's faster. It's not. Uh, it depends on the evaluation, and that's a tricky thing actually. Ah, so other than that, it's language independent. So you can use gRPC with your whichever language you want: C, C++, C Sharp, Objective C, Kotlin, Java, PHP, Python, Node. Like yeah, they have a lot of language this which they support. They have different connection options. So usually, if you have worked with streaming data, so usually when you want to stream data, you probably need to go ahead and use some different API, maybe uh, what was that API? Client.io, socket.io, socket.js. So yeah, gRPC out of the box supports all different types of communication, unary communication. So that's basically a single request and a single response, client-side streaming, server-side streaming, bidirectional streaming. So it supports all of the connections by default out of the box, and it has a very good layer of abstraction. I'll talk about this as well. So you'll get to know how and why interfaces are important. So you might have learned about interfaces in your objective OOPS class, but now you'll get to know how interfaces are actually important in real life development, where they're actually used, because that's something which I also learned by doing learning gRPC. And also gRPC is strongly typed. With this is a very important key feature of gRPC, because if you're using REST or JSON and API or SOAP even, JSON is not strongly typed. Uh, Whenever you like, for example, if you're using an API, right, the API will have a documentation stating that you should send this much data, how this is how you should send it, and blah blah blah. But if somehow you miss one, suppose is suppose you're sending log, right, to an endpoint. So in that you should have the log message, you should have the time, you should have the system name, and maybe one or two three things. But suppose if I miss the system date, uh, and maybe the backend is not checking it, and the database allows saving an entry without a system date. So the API call will go through, and the log will actually be saved without a system date, the date or the time at which the log was executed or sent, or yeah. So that's a bad thing. And you can obviously do server-side checking, but that's an extra step that you have to do yourself. And if you're working with a very, very big code base, it's possible that you might miss some checking. So gRPC comes with strongly typed, so it supports types, and if you suppose miss anything, it will throw out an error outright. You cannot send extra data, like extra keys. So in HTTP, normal REST request or API request, if suppose the API accepts three columns, three data points, you can send 5, 6, 7, 8, 10 even, and it won't throw an error back to you. It will just keep those three which are important, and it will not even care about the other ones. But gRPC cares, and you have, if gRPC expects three data points, then it should receive three data points. That's it. So yeah, it's very strongly typed. Okay, yeah. So I was talking about how gRPC is efficient when you talk about um, yeah. So in the second point, high performance, it says the gRPC can be 5 to 8 times performant than REST plus JSON, and that's because a lot of the times developers miss out on this big feature that there exists something called as HTTP2. So a lot of the servers, even now, right now, uses HTTP1, and a very good example of that is the uh, GitHub IO server. Uh, I checked it last night. So I checked an API which was hosted on GitHub IO server. and the response which I got was in HTTP 1.1. So that's not a very bad thing actually, but the advantages which HTTP 2 can provide you provides you is, can be very helpful depending on what kind of work you're trying to do. So yeah, uh, what HTTP how HTTP 2 differs from HTTP 1.1, which was the last version of HTTP, which was released in I think 1990s, somewhere around 1990s. So it has been over 15, 20, more than 20 years that HTTP 1 has been around. And I think HTTP 2 came around 2015 to 2017, somewhere in between. So HTTP2, what it supports is multiplexing. So before that, if you had to create three different requests, like if you had to make three different requests for one for your HTML file, one for a CSS file, one for your JS file. So one way was to do is create one HTTP channel, send the request for HTML, send the request for CSS, send the request for JS. To work around this and still be using HTTP1, uh, people people started creating three different channels, and creating and dissolving channels is a very in CPU intensive task as well as network intensive task. So creating three different channels for three different files so that you can call them parallelly, because you can very well call HTML, CSS, and JS files parallelly for efficient use case. But that's again CPU and network intensive again, creating three different channels and just for single use case. What HTTP2 did was it allowed you to multiplex. So using one single channel, you can call as many requests as possible using the TCP lane, using the TCP layer. And yeah, using that you can in this example, it's calling on the right side the HTTP2 multiplexing. It's first getting the HTML response and then getting the CSS and JS response. Technically, you can call all the three requests. You can make all the three requests one by one, but it's doing this for safe case because you don't want the CSS and JS to be received before HTML. Because even if you make the HTML request before making the CSS and JS request parallelly, there is a possibility that the CSS and JS can return back to you before HTML. So just for safety case, in this example, it's making the request HTML first and the CSS and JS in parallel. So yeah, but still that's efficient. That's one less request you have to wait for. So that's HTTP2. Okay, and I think I covered most of the points about the advantage gRPC and whatnot. HTTP2, yeah. So a good thing. Yeah, sorry. Uh, this is something which I asked everyone, whomever I tell about gRPC. So I asked them what is the full form of G, what is the uh, meaning of G in gRPC. People usually respond with Google because I bait them by telling that gRPC was built by Google, but Google did a trick on us. G in gRPC does not stand for Google. Actually, there's a different meaning of G in every version that they release. So this is just a simple fun fact I'm throwing here for no reason at all. Uh, Google keeps on changing this what G stands for. In the first version, stood for gRPC. So the full form of gRPC was gRPC Remote Procedure Call. Uh, but then after that, I, I'm not sure if the list is visible on the stream, but yeah, you can check. There's a whole README where they have listed out all these names for every version. From which and the screenshot is from there as well. Okay, yeah. And I probably am looking like this person. If you know him, then good for you. Uh, babbling, uh, babbling about how it's more efficient, how in middle out algorithm is efficient than using JSON, and how protobuf is better. But just bear for me 5 minutes more, and then we'll get to code. Oh, okay. Let's talk about code somewhat. Like this is technically code. So now we'll be talking about how gRPC servers communicate and how you can create a gRPC servers of your own. So a gRPC usually uses protobuf. You can use JSON as well, but the whole one of the major reason of using gRPC is protobuf because it's efficient. Not by a lot, but yeah, it is. And if you have a lot of requests, and overall, it will the net gain would be visible at your end. So yeah, gRPC typically used with protocol buffer, which is also called protobuf, uh, and it's an interface definition language. So interface definition language isn't mm, is a language where you define an interface. So suppose in Java, if you have usually noobs, Java is taught, right? So in Java, you can define an interface and then you can implement that interface, right? So what gRPC does is it uses protobuf, which usually has a .proto file, and you define the interface in the proto file using the protobuf syntax, and then you use these code generators which are available publicly to generate the interface that you wrote in the .proto and convert it into whatever language you're using, to C sharp, to C++, to Ruby, to Python, whatever you prefer, right? So yeah, that's how you generate an interface, and then basically two interfaces are generated by this method. One is the server and one is the client. You have to implement the server and the client, and then you can communicate with, you can make calls from the client to the server. Okay. So yeah, this is how the development cycle of gRPC works. So basically, you define the protobuf, you compile the protobuf by compiling, generating the code in whichever language you prefer, Java, Go, Ruby, and once you generate the interfaces, you can implement the interfaces to servers and clients. Okay, so but how does the proto looks like? Right. So this is where now we get to coding. Okay, I'll try to create a simple project in which I'll show you how we can define your our profile, how we can create a communication, how we can communicate between uh, a client and a server. So just wait a second. Let me stop sharing my screen and I'll share my VS Code. Just wait a second. Okay, so I'll create a project called uh, please work. Okay, I'll open this in code. I'll share my screen. Just wait a second. Please work. Okay, hopefully this will get, yeah. So this is our workspace. Okay, so first we have to create a proto file. As we learned that first we need to create a proto file. So we'll do a message.proto. Okay, so now that we have message.proto, let's go ahead and wait a second. System is lagging at the worst times. Okay, yeah. So actually, Proto is a completely different thing than gRPC. It exists in its own sphere. gRPC uses Proto. Uh, so yeah, so basically, Proto has evolved so much that there are now three versions of Proto. So yeah, Proto 3. So now we'll be defining that we are going to use the version 3 of Proto. Okay, we have to we have to, oh my god, what is happening? We have to name the package. So I'll name the package as message tool. Okay, so in this we will create a crvsv service which will be uh, messaging. No, let's name this something better. Uh, Hello. Okay. Okay. And in this service, we can define our APIs. So this is where we will define our interfaces. So consider the service as a class, and inside the class we can have different methods, right? So we can define methods like by writing RPC, right? So it's RPC method. I can say uh, hello server. Okay. And in hello server, suppose I want to send some message. So okay, but what can I send? I can type a string, but actually that's not how it works. So to define what you want to send, you have to create these. There are, let's say I cannot name the package as message because that will create problems afterward. I just noticed. Okay. Uh-huh. Mess. Yeah, mess. This is definitely a mess. So, so actually, you have to define messages, and you can have the you can name them. So messages are basically struct. You'll see just in a bit. Suppose I create a message saying hello message. Okay, and in this I can have suppose I want to have a string name. So I want to pass my name and I want to pass the message, whatever message I want to send, and then I can send in the message hello message, and then this function should return again a hello message. Maybe I can create a different message hello back message. Okay, so and I think I'll have the same definition for this. You can use the same hello message, but I am just creating this another second struct, basically structure, and I can say hello back message, and this is it. Yep. So this is how created. Oh wait, the font is smaller. Let me increase the font. Yeah. Okay. So this is how I created a method hello server. It's an RPC method. It accepts a hello message. It returns the hello back message. The hello message has two properties, name and message, and the hello back message also has two properties, name and message. And suppose due to some reason afterwards you want to change whatever you're sending back. Suppose you want to send the IP back as well as the IP of the server for some weird reason. You can send that. You can add the here as well without changing this. So your method definition does never changes. And in the method definition, only one parameter, it accepts only one parameter and it returns only one parameter. Suppose if you want to have two parameters, you basically create a message and do it this way. Like suppose if I want to send my location as well. So location, I will have suppose int 64. Uh, okay, how can I latitude and six int 64, not 43, 64, and lat I can call this one int long 2. And suppose in hello back message I want to send my location as well. So I can call this location location equals to 4. So this is how I can have structs inside of struct, and in the hello message basically I'll have my name, my message, my IP, and my location. So this is how we can define objects, basically objects or structures, and to send message back and forth between servers and clients. So for now I'll have just these two. Return. What's the problem with return? Oh, right. It returns. Yeah. Typos. Yeah. I mean, okay, so yeah, now we have our message.proto. Now we want to compile this. Okay, so let's open a terminal. Okay, too big, too big. Okay, so now we want to compile this. So to compile this, actually, first you would have to install pip install um, gRPC underscore tools. Yep, I think this is it. It's already installed on my system. What just happened? Install the official package pip install. Okay, it's gRPC IO tools. Okay, got it. So you would have to first install this, but it's already installed on my system. So I can go ahead and I can first type clear, and I can basically compile this uh, proto interface definition language into Python files, and this will be auto-generated. I just need to run this one command. And anytime I update the proto file, I have to run this command again. And you can pretty much have this in your build script as well, so that every time you build your server, it will first run the script to generate the interface definition, and then compile it with all your other server and client and everything else. But yeah, right now I'll do this manually. So I have to write gRPC underscore tools dot proto input. So the input is in the same folder, and I want Python out. I want that to be in the same folder as well, and I want gRPC. Is it dash or is underscore out to be in the same directory? Yep. And now I have to specify the message proto and enter, and yes, these are the two files which got generated. I can go through these, but these are like very much auto generated, and it's it's better to just leave this as it is right now, because it can take an hour just to go through these and explain what these do. So basically two files are generated, a message pb2 and message pb grpc. Okay, I'll explain what why two are there and what. So I think we can see this here as well. So this is the main one, gRPC pb2 message underscore pb2 underscore grpc. So this has the hello stub class, right? And this has the hello receiver class. Sorry, the hello receiver class, hello server. Sorry, service. Did I mess up in the name or what? Hello server, hello service. Why is it service? Okay, yeah, we'll see this. Even I don't technically, even I don't understand this fully. I know how to use them, and that's my. And I try to limit myself till there. Um, okay, so yeah, let's try creating a server. Now, since these interfaces are generated right now, I hmm, okay, I need to import them as first. So I need to import message pb2. I need to import message pb2 underscore grpc, and I of course need to import grpc, the library. And what else do I need? Hmm, I don't think I need anything else right now. Okay, let's see. Okay, so I'll first be calling a run function, and I'll define the def run function here. Okay, and in this run function, so this is a server, right? Okay, instead of run, better call it server. Yep. So in the server, let's basically create a server object, which will come from gRPC class dot server, and I need to call. Oh yeah, I need one more thing. I need one more thing, which is from component import futures. Yep, I think this is it. Um, hmm, okay. I'm not sure if this is needed, but yeah, let's see. Just wait a second. I'm not sure. Yeah, okay, yeah. Futures, yes. There should be something called, yes, thread pool execute. Got it, got it, got it. Yes. I was wondering where we define the max workers. Yeah. So this is where we define the max workers. So basically, the server which you create will execute all the commands in different threads from different servers. Suppose if different uh, requests are coming from different servers, so this server will create different threads with the same server and basically handle these requests. So here I'm trying to limit the server, how much threads the server can create, because it's my local machine. It will not create more than this because there's no one requesting for this server. But yeah, it's just a good practice. Um, hmm. Let me just close this as well for now. Okay. Okay. So we have the route. What was the message? Message PB to gRPC. So in this, we should have a add hello server to server. Yes. Mhm. So here we'll be adding the service, so which we will be implementing. So let's go ahead and first implement this service. So we will have a class. Message servicer, and I'll be taking in the interface. And Python has this weird thing. Usually in languages, you take the write the interface here, but Python has this weird thing where it takes the interface inside the curly braces. Very weird. I still can't get my head over this, but yeah, this is how it works in Python. And we have message pv2. I don't think it should have been message. It should be hello service. Yes. So here you can see there are three things: hello, hello servicer, and hello stuff. So hello, as you can see, is the service, main service, right? And inside of this, uh, what happened? Hello. Inside this, there's hello servicer and hello stub. So hello servicer is the service interface and hello stub is the client interface. So whenever you want to implement the service, the server side, you take the interface from the servicer, and whenever you want to implement the stub or the client side, you take the interface which is the stub interface basically. So here we want to implement the server. So hello servicer. Cool. Got it. Um, should usually have this, but uh, there's nothing needed, so I'll just do something like self mm, message equals to none. I don't think I will use this. Okay, so now I need to get the method name. What is the method name? Hello server. Okay, so I need to override this hello server, and this should be receiving the self object, the request, and the context. Okay, and what else do I? Is it needed? Okay, okay, okay. I need to take in the request. So suppose the client sends me a hello message. I can print the hello message. Let's do that. Print request dot. It should have a name and a message. So I'll do dot name plus colon plus request dot message. Got it. And hmm, suppose I want to say send the same thing back to the hello back message. Okay. So I need to create a hello back message because a message is basically a struct. So you need to create this struct to send it back. So usually in Java you use builder methods, but because this is Python, everything is very uh, there's nothing. uh, and there's no limitation. Yeah, usually Java has this builder which protects you from changing the stub values directly, so that you only use methods and functions to change the values internally. Yeah, since this is Python, we can go ahead and just create a. So in the message PV2, you'll have the structs. So you saw that the message PV2 gRPC has the hello servicer and the hello stub. So these are the main classes, and the message PV2 usually has the all the messages which you define, uh, messages or the structs you define, right? So this has the hello message back. I need to create this, and in this I need to have a name and a message again. So let's say name. Okay, let me define this statically. Okay, so whatever you send, no matter, the messages would be uh, working. Got it. And I can do a return. Okay, I need to first store this in some variable. Res response, and I can do a response. Cool. So now that I have implemented the interface hello servicer, and the message is called message servicer, I can add this here, uh, and this should take one more thing, I guess. Yeah, it should take the server as well. Yeah, done. And then I need to take the server. I need to add insecure code because I am very insecure. Uh, just a useless joke. I can have any port. I'll go with 505050. Just feeling like it. Server dot start and server dot wait for termination. Great. The best thing, one more great thing about gRPC is that you notice server dot wait for termination. So usually, if you do a hard terminate, the gRPC will, whatever the APIs which are already in request, it will first handle those and then it will terminate the server. So that's also a good safe feature, you could say, that no API will be cancelled if you do a hard uh, control C, or if you try to shut down the server directly, something like that. Uh, yeah. So yeah, this is very simple. Uh, let's see. I've implemented, and because you cannot see the whole. I chose Python because I'm very comfortable in Python, and it's very fast to do this in Python, and because I also have very less time. And if you actually do this with a strongly typed language, you'll actually see a lot more advantages to this, because Python isn't the best when it comes to oops or uh, uh, oops, or basically statically typed, interacting with statically typed things. So when basically, suppose when I wrote message.p.2, I wrote hello message back. Inside this, it should tell me that what all is expected, whereas Python is like, nah, nothing is expected. You can do whatever you want. Uh, yeah, sorry, here, yeah, it says none. Whereas it should show that, okay, I should, it accepts a name and a message parameter. So this all actually comes, which depends on the language to language. I hate Python for this, but I mean, it's fast to, but I love the fact that it's very quick. If you want to do quick tutorials, Python is very good for that. Okay, so yeah, this is servers created. Let's not waste any time. Let's create a CLI client.py. Cool. Okay, so client should be faster. Like, okay, I'll do a, I'll try to do this as fast as possible, and import message pv2, import message pv2 gRPC. Okay, I need to have a run function, and in the run function we'll have def run. Okay, with in this I'll do a cha. So uh, if you know about HTTP creates these channels to communicate with the server. The communication between server and client happens through channels. So gRPC also creates these channels through which communication happens. So this is what we are trying to create here, a channel. So I'll do a gRPC insecure channel, very insecure on bad things, local host 505050. Very cool port. I'm not even sure that 6-digit ports are valid or not. I hope they are. Okay, never mind. We'll see that. Okay, what else is needed? I need to have a function. Okay, I want to call the hello service server. For that, I need to send a hello message. Okay, so send hello message function. Okay, it should take in a stub. So a stub is basically an interface through which you communicate to the backend. So the client has the interface. The same interface is shared between the client and the server. The client uses this interface to call the method, and this method call travels through internet or basically web, goes to the server, gets executed, and then it returns something back. So the stub is basically the interface through which you call the methods which get transmitted through the web. So you can consider stub as basically your any library through which you make a HTTP call like that. But instead of HTTP call, it's a function call. Okay, so stub. Hmm. What else? Okay, I need to pass in the stub first of all. Great. So I need to create a stub. So stub can be created using the interface. So message pv2 gRPC dot hello stub. So you see it's called stub. One is receiver, one is stub. Servicer, one is stub. So and I pass in the channel and what else do I need? I don't think any else. Hello message. Send hello message and then I need to do stub. So I'm sending in a stub. Hmm. Okay, yeah, I need to write something here. Okay, so I need to create a first of all a hello message. Okay, let's take this as an input. Okay, name. So I'll take this as input. What am I doing? I cannot even type name. Uh, message input message. Hmm. Hello message. So I need to create a message object from the structure which we created. So the structure is usually in the message pv2 and it should have a hello message. Yes, I need Python says nothing is accepted, but actually you need to pass in the name. Uh, Not the best language to work with gRPC. Uh, and since I had this working and I did not had time to actually switch it to any other language, switch this preparation. So yeah, I'm going with Python, but I would recommend doing this in whatever the language you prefer. I think it supports Node.js and yep. So that is you can do this with Node.js, C Sharp, whichever you prefer. Okay, yeah. So we have hello message with us, and now we want to send this hello message to the server. So we'll be using the stub, and the stub should have, again, it shows nothing, no suggestions. But the stub should have a hello server method, even though it does not show, it should. Uh, and I can show you how. Actually, I don't know why Python does the Python. It's not. I don't think it's the problem of Python. It is the problem of the linter or the Visual Studio not supporting gRPC methods. Something. So if you do stub dot, now here you can see hello server. So okay, why am I even calling a method? Let's just have this in one single function. Why am I creating useless functions? Huh. Okay. So this is done. This is done. Yeah. So I created the hello message. I have the stub. I can call the hello server. I can do hello message, and I should have a response from the server, and I can print the response dot was it name plus um, response dot message. Cool. uh, and the server does this as well. It prints whatever message it receives, the request it receives, and the client prints the response that it receives. Hmm. Yeah, I think we are done. So basically, will be having these two different files running parallelly into a different command prompt, and they'll be able to communicate with each other using gRPC. They'll be able to communicate internally using gRPC. So let's have another bash open here. Yep. Okay. So let me do an ls. So we have a client and a server. Okay. I can do Python server first. Okay. Server takes no argument. What just happened? Wait, which line? Line number 18. 18. Server takes no argument. Hmm. Uh, okay, okay. It's it's small s. It is a small s. It's my mistake. Uh, if the server actually starts, uh, it should print server started just for some confirmation. Yeah, server started. Great. And I can do ls here, and I have the client.py here. Cool. So I'll do this. It's asking my name, J message. Uh, Working? Question mark. Okay, it's not. Okay, okay. Let's see. What just happened? Exception calling the application. Uh, okay, in line number 17 and in line number 14. Okay, so this is the problem. Why is this the problem? The hello back message takes a name and a message. It takes a name. Hello message. It takes a name and a message. The This happened in line 14, right? Where is the error log again? Hmm. Line 17, and then 17 which calls this, and then line 14 which actually calls the stub hello server. Okay, mistake again. So the stub should, no, it has a hello server method. Um, this should be fine. Um, mhm. Hello message is a hello message. It does the server even did not receive anything. So there was a error in sending a message. Hello message. The name is name. The message is message. Did I miss something? The name is the message, hello message, and it accepts hello message only. No? So there should not have been any error. Uh, this is string, this is string. Uh, I'm passing this here. Um, Let me just add here uh, hello message start. Let's just see what happens. So my name is Jay. I'm working. Okay, not working. So okay, it printed out Jay. So the creation of the object is correct, uh, but the server is not able to respond. Is that so? Okay, let me just add a print. Uh, Java, very professional logs, debugging methods. J working. Okay, so the request did not go through. Hmm.
I guess there is something like missing a parameter,
Yeah,
some
yeah.
context parameters missing, like exceptional calling application hello server missing one required positional argument context at the end of the log. You can see that.
Okay, 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 okay. But um, this technically should not happen. Okay, let me check. Hmm. I want to.
Or wrap it up in a try catch block can work, uh, like catching the error if it is.
Hmm. Yeah. Not sure. I think it would again throw out the error here only. The error is stop hello server. So it's the hello server accepts only one parameter, hello message. In exception calling exception hello server missing one required for hello server one argument context to one string created. Yeah, this exception calling message one required. So context is missing, but I am passing in the hello message. I think that's all it requires, right? What else could be? What else could it be? Let me see if I can quickly.
Instantiate the server code inside, like where you are building the server in the server.py.
Mhm.
You can
No,
try to
yeah,
instantiate.
the message receiver and the
Yeah,
server
just
is all.
instantiate it, message servicer, and just add. You can add parenthesis, so it
Oh,
will actually
damn!
instantiate.
Did
Yes.
I
So it
think
will create an object
this?
over there, and like the class has the constructor, right?
Yeah,
Yeah.
I
Now
think
we
that
can. Now it
was
will
the
work.
message.
Yeah.
Yeah,
Now
that
it will
should
work.
work.
So we are not getting
The
the
server
context.
has started. J, the message is working. See, oh, whoa, damn. Thanks a lot,
That's
man.
cool, man. Yeah.
Okay, okay, yes. I forgot to create an object. I was passing in the class
Yeah.
name.
Exactly. No worries. That's really cool
Okay.
stuff. Yeah.
Yeah, I actually wanted to showcase a bidirectional streaming where you could actually uh, do create a chat application with gRPC. But yeah, I think we are out of time. Uh,
Yep. Yeah, we can
or
like have a different session of like creating a chat application or using gRPC. That's something
or
amazing. Like I learned new stuff. Yeah.
or maybe I can show the actual application right now, just for 5 minutes. How it, uh, just can I have 5 more minutes? I think
Yeah,
I'm
yeah.
overshooting already.
If it is like feasible in 10 to 15 minutes, we can go with it. No worries.
Yeah, I won't be actually building it. It's already built. I'll be just
Okay.
showing the application.
Sure,
Yeah,
sure. Please, please. I'd be glad. Yeah.
yeah. Let me just open the application. So, uh, okay, this is one dash. This is one dash. This is one dash. Okay. Done. Yeah. Okay, I'll share my screen. Window. Uh,
Yeah.
Chances branch. Just yeah, in a second. Yeah. Yeah. Okay, so I'll quickly go through over this. So I have this one proto, which I have chat app proto. So
Yeah.
it has a message chat. It does a chat stream. It has a RPC method called chat stream. I have added these two keyword stream, which basically specify that the request would be request and the response would be streaming response. So and suppose if I remove the stream from here, this basically means the request would be unary one and the response would be stream. So this is server streaming. And if I remove from here, this is client streaming. But yeah, we'll be doing streaming from both sides. So we have stream on both sides. We have a simple
Yep.
chat uh, object, message chat message, and basically I'll be running. So this I've done in C sharp because that's what it takes a bit time, but I did this before the talk and just to check it out if it's actually working or not. So I'll just showcase it working first. Okay, so I'll do a .NET run. So the server should be up and running. Yeah. Okay. It should be. Never mind. And I'll do a .NET run on the client. So this is the chat app client, and I have the chat app client in Python. So here I'll be trying to show how different language applications with different languages can communicate through the same server. So
Oh, that's nice.
I, I have a Python client, right? So it's asking my name. So let's suppose my name is J C Sharp, and suppose here my name is J Python. Right? Uh, so here I can say hello Python, and here you can see this
Wow.
is coming back, and I can say hello C Sharp, how are you doing? Uh, it comes back as JPython is saying hello C Sharp, how are you doing? And these are the both clients, and if you actually go to the server, uh, the server is logging. Yeah, the server is created, new listener, hello Python, how C Sharp, how are you doing? And yeah, this was a Python client. I used the Python client.py. You can check this. It's not a C sharp client. And here I did a .NET run. So it's a .NET application written in C sharp. So
Yeah.
yeah, two different servers with different languages are able to communicate. That's also a cool thing. So yeah, that's pretty much I'll be talking about in code. I'll just
Yeah.
end it with one last slide. Window. Yep, here it is. So yeah, so we saw how a proto file looks. Great. We saw how we can generate classes. Time to implement server, we did that as well. Time to implement the client, we did that as well. Hopefully by this time you're saying it's working. Thanks to Abir for that one mistake, but yeah, it worked at the end. Uh, yeah, I wanted to talk about this, but basically Spotify was using a different RPC framework of their own, but they moved to gRPC as well because the performance and the open sourceness of the application has the great tooling features around it, and that's why Spotify who had their own RPC framework from which was Hermes, which is Greek god. They moved from that to
That's
gRPC,
awesome.
and this is why it happened. There was no tooling around their own built application because it was an inbuilt application inside of Spotify. No one else used it. The learning curve, nowhere outside of Spotify knew about this because, of course, it was an internal tool. No one else knew the documentation or how it works. So as soon as someone joins, they had to learn this, and as well as feature management, anything they wanted, they had to do them by themselves. So that's
Mm.
where they dropped their own application. And just some fun facts. Netflix is one of the major companies which uh, was one of the few first ones who came into this microservice environment, and they have around 500 microservices of their own API gateways, which handle around 2 billion APIs daily, and they also use gRPC internally. And yeah, I was talking about how Google takes around 10 to the power 10 RPC calls each second. So that's the level of API calls that are being made by Google. So they have tuned this gRPC to such level that suppose even if someone slacks in Google, right, and now gRPC takes 1 microsecond more. Now take this 1 microsecond, multiplied by 10 to the power 10. Now compare how much more time they're spending on their servers just because of 1 more microsecond. So that's the level of tuning Google has done on this project. And this was actually being used from 2000 for around 15 years, at which they open sourced this. So it has went through a lot of versioning and changes, and yeah, it's very performance and ready to be used in high optimized servers. So in which scenarios you should prefer to use gRPC? Uh, Microservices are the best examples where you should be using this. They're trying to make this working for end-to-end web clients, so you can make calls from your browser as well, gRPC calls, but it's not quite ready, I would say. Yeah, might do a cool demo. So the cool demo was the application, the Python and the .NET application communicating through the main server. So I was thinking of creating this on stream, but yeah, I think I misunderstood how much time it takes to create projects on stream. Yeah, never mind. Uh, these are some of the references. I don't think this is important. And yeah, that's it. So follow me on Twitter. I'll probably be sharing the code base, the GitHub repo, and the slides and everything. So yeah, that's it from my side. Hey, Abir, I think
So,
you are mute.
yes, sir. Sorry. Yeah, thank you, Jeff, for sharing all this about gRPC, the fun facts, Netflix, and so many stuff. Like I really like those fun facts about microservices, and yeah,
Yeah,
I feel now like our hackers are like got this broad enlightenment on how to like use what do you say, uh, the client side, like if you have two different code bases, how do we communicate between them, like each job. So this is
yeah,
kind
yeah,
of usually like folks feel that it's not possible, but yeah, via grpc it is possible. And this is kind of like an adapter, you can think it of like all the
yeah,
experienced folks, it's something like an adapter design. So yeah, so thank you, Jay, for sharing all this, and good luck. Yeah.
yeah. Best of luck to all the participants in the hackathon.
Yeah. Yeah, okay. Good.
Okay, bye everyone.
Bye.